Hello students, welcome to aimsindia online classes. This is a chemistry session. Here we are discussing about the chapter changes around us. So in the earlier sessions we have seen certain types of changes. Now also in this session also we are going to see the classification of changes into different kinds. Okay, let us continue that here. So the classification of changes based upon the energy, let us see now. So based upon the energy also, changes can be classified into two types. Let us see what are those two. Energy initiates a change. When any change takes place, energy is either evolved or absorbed in that change. Okay, some changes they absorb energy while it is happening, and some changes they release energy while the change is being happened. Okay, based upon this, either energy absorbed or evolved, changes can be classified into two types. They are exothermic changes and endothermic changes. Let us see those. What are those two? First, let us go through the exothermic changes. The changes which are accompanied by the release of energy are called as exothermic changes. For example, burning of magnesium. Okay, when you burn magnesium, what happens? It continues to burn with dazzling white flame, and it releases some sparks also. Means when magnesium is burned, it releases heat energy. Such kind of changes in which energy is released out are called exothermic changes. Okay, let us see some more examples for these exothermic changes or exothermic reactions. For example, during making of ice cubes, heat energy is released out. Means while while water is converting into ice solid form, heat energy is released out from the water. So as heat energy is released out, that conversion of water into ice we can say as exothermic change. Let us see one more. When water vapors condenses into liquid water, we know when water vapor touches cooler parts of the any surface, then it starts converting into liquid form. What is happening there? Water vapor releases out certain heat energy from it, and hence it converts into liquid water form. So this change is involved with the evolution of heat energy out, releasing of heat energy out. Hence the condensation of water vapor into water is called will come under exothermic change. Let us see one more. Flame of candle or burner is an example for exothermic change. What happens in the candle flame? When it is lighted a candle, it continuously burns out and gives energy, heat energy out. It releases heat energy out. So burning of a candle or burning any burner on the stove, this all will come under exothermic changes. One more. During mixing of water and strong acid, heat energy is released. Yes, this also one of the examples for exothermic changes. When you add a small quantity of a strong acid like sulfuric acid, what happens to the water? Then heat energy is evolved out. So it also comes under exothermic change. This addition of acid, concentrated acid to large quantity of water is called generally dilution of acid. In this dilution of acids, small quantity of acid will be added to water, drop by drop, and it will be stirred continuously. There it releases heat energy. So it comes under exothermic change. So we should not add suddenly the strong acid to water. Slowly we have to add, because it may release large amount of heat energy which may burn our skin. It may damage us. That's why it should be done very carefully, that dilution of acids, which should take large quantity of water in a beaker or any bucket like that. To that, this concentrated acid or strong acid should be added drop by drop very slowly with continuous stirring of that liquid. That is called dilution of acids. So this dilution of acids will come under exothermic changes because heat energy is released while adding this acid to water. One more example. When a bomb explodes, large amount of heat energy is released out. So explosion of these bombs also will come under exothermic changes. So these all are changes in which energy is released out, heat energy is released out. Hence these all are called as exothermic changes. Okay, now let us see another type of change based upon the energy change, that is endothermic changes. A change that is accompanied by absorption of heat energy is called endothermic change. For example, state conversion from solid to liquid. What happens in that? Well, suppose if we take water, if it is converting into ice form, what to be done there? It should be cooled. Means state from solid to liquid, conversion of ice into water. What to be done? If we take ice cube, to convert that into liquid water, what to be done? It should be heated. Heat energy should be given to that. Then it converts into liquid form. So this change of solid into liquid form involves the absorption of heat energy from the surroundings, and hence this is called endothermic change. The change which occurs by the absorption of heat energy are called endothermic changes. For example, we can say this as shown here, conversion of ice into water involves with the absorption of heat energy. So it is one of the examples for endothermic changes. Let us see some more examples for these endothermic changes. In evaporation process, heat is absorbed by the water molecules at the surface of the water. Hence, evaporation is endothermic changes. So what is happening in the evaporation process? Water from the water bodies like oceans and these all, from the surface, water molecules present on the surface of these liquids, it absorbs heat energy from the sunlight and converts into water vapor like this. So while converting like this into from liquid state to gaseous state, it absorbs heat energy from the surroundings. Then these water molecules converts into gaseous form. So we can say this evaporation is done by absorbing heat energy from the sun. That's why evaporation is an endothermic process, as it is absorbing heat energy from sun. Let us see some more. Heat is absorbed during melting of ice. So when ice cubes are melting out, they absorb heat energy from the surroundings and then they convert into liquid water form. So as energy is absorbed in this, it is also one of the endothermic processes. Okay, melting of ice is endothermic process. One more, heat is absorbed in baking bread and cooking food. So for baking of bread and for cooking of food items, we need to heat them. So by absorbing heat energy, these changes occurs. Baking of bread and cooking of food, these all are done by heat energy absorption. So they come under endothermic changes. One more, photosynthesis. Photosynthesis is one of the endothermic processes because it will not happen without an external source of energy, which in this case is sunlight. Okay, this photosynthesis will be happen in the presence of sunlight only. By absorbing heat energy from the sun only, this process of food making plants, which we call as photosynthesis, it happens only in the presence of sunlight. By absorbing energy from the sun only, this process occurs. So that is why this photosynthesis process is called an endothermic process. Of course, it is done there the combination of carbon dioxide and the carbon water from the roots, this all will be combined only in the presence of sunlight. That's why it is called endothermic process. Okay. Now let us see another type of changes, another classification of changes, that is expansion and contraction of materials. Heating and cooling of materials can make them change. Yes, most of the substances, they change by heating or cooling. This change occurs in all materials generally, from water to metals and metals to air. These all will change their size when they are heated or cooled. But the effect of heating is opposite to effect of cooling. Both are opposite actually. Okay. Now let us see what happens by heating. Heating a substance can make it expanded, but degree of expansion differs in solids, liquids and gases. Gases expand the most, while solids expand the least. Anyhow, all the materials generally on heating, they expand, but this expansion will be different in different states. Gases expand to a lot, they expand most, while solids expand a little. Okay. For example, metals expand on heating. Railway track consists of two parallel metal rails joined together. Have you observed metallic train rails? Railway track rails? Have you observed those? If you observe, there will be two parallel metal rails joined together, isn't it? So small gap is left between the rails as there is an expansion of these rails in hot summer weather. So if you observe these metallic rails, at the joints they leave some small gaps between the rails. This gap is left wantedly because these rails are made up of metals, steel. In the hot weather, these metal rails may expand. When they expand, this gap will be filled. If no gap is left here, these on expansion, they may bend into different shapes. Instead of being straight, they may bend. So that may cause some accidents of trains. So to avoid that, while it is expanding, to cover that, they leave some gaps between the rails of these railway tracks. Okay, when they expand, they cover this gap. That is why they leave certain gaps between the iron rails of these railway tracks. Okay, this is one of the examples for expansion. Next, let us see opposite way for this is cooling. Cooling of a substance results in contraction generally. So in the here also, so in the contraction also, least in case of solids and it is highest in case of gases. That means solids contract the least while gases contract the most. For example, a very hot glass cracks on putting it under cold water. If you take a hot glass, if you keep that under the tap which is running with the very cold water, immediately you can observe certain cracks on this glass. This is because the outer surface of the glass, when it comes in direct contact with the cold water, contracts. We know when on cooling, generally materials, they contract. So if you bring this hot glass under the cool water under a tap, immediately you observe some cracks because the outer surface of the glass which is coming in contact with the cool water, immediately it contracts. Okay, but when it contracts more actually when compared with the inner surface of the glass that is not in direct contact with the cold water. So the inner surface of the glass is not in direct contact with the cold water, so it contracts slowly. But whereas the outer surface which is in direct contact with the cold water, it contracts a little more than the inner surface, and hence we observe certain cracks in that glass. So this is because the outer surface is in contact with the cold water directly, so it contracts immediately. But the inner surface is not in direct contact with the cold water, so for its contraction it takes a little time, hence it take time to cool down and contract. So as there is a difference in the contract speed, the outer surface it is contracting faster, so certain cracks are observed on this glass. This is because of the contraction. Okay, materials on cooling, they contract. Okay, let us know few points about these contractions and energy changes. Respiration is an example of exothermic change, because during respiration glucose molecules break down and energy is released out, which can be utilized for our day-to-day actions. Similarly, digestion of food is also one of the exothermic changes. So what is happening in the respiration? The glucose present in our body, in the presence of oxygen, it converts into energy, which we are using for other day-to-day actions. So here energy is released out. That's why you say this respiration as one of the exothermic processes. In the same way, this digestion of food is also one of the exothermic changes, because by the digestion of food energy is produced in our body, which we are using for our daily metabolic system works, day-to-day actions, we are using that. So there digestion of food is also one of the exothermic changes. While energy is involved in all types of changes, it is not always easy to see these changes happening. For example, we cannot see the energy involved in case of weather changes or drying of clothes. We cannot see how the changes are happening, but we observe the final result, isn't it? When you keep these dry clothes in the open air, what happens? After certain time they become dry. How it is happening? Here the water present in the clothes, it is converting into vapor form, it is evaporated. There the change we cannot see how it is happening there, but final result you can see that the clothes become dry. Some chemical changes require the presence of another substance which itself does not undergo any change. Such a substance is called a catalyst. Okay, some chemical changes, they occur in the presence of a particular substance, but actually that substance won't involve in the reaction, but it encourages the reaction to be happen. That is a kind of substances which make the changes to occur without involving in it are called as catalyst. Okay, the substance which makes the change to occur without involving in it is called a catalyst. For example, chlorophyll in plants is a catalyst because it changes the water and carbon dioxide into food, but itself it does not undergo any change. So in the presence of chlorophyll only, water and carbon dioxide combine together to form food in the form of carbohydrates, isn't it? So this happens only in the presence of chlorophyll, but this chlorophyll will not be changed, it will be remained the same, it does not undergo any change. Such kind of substances in the presence of which a change occurs and it won't involve in the change is called a catalyst. So in this photosynthesis process, catalyst is chlorophyll. Okay, that is about the different kinds of changes. Thank you for watching our video. Please subscribe our YouTube channel aimstoday and visit our website aimstoday.in for latest updates on recorded videos.